If you're like the majority of us, your mini mill came with very little in the way of accessories. Now while it might not seem like it at first, this really is a good thing, in that it leaves you able to outfit your rig with the tools and fixtures that will serve you best in your particular hobby or avocation. Hobby machinists usually have certain goals they wish to pursue, and each goal will require different tools and techniques to be accomplished. Each discipline will have specialized tools, techniques, fixtures, and setups that will become a regular part of your repertoire. But no matter what your specialty may be, we all use certain basic elements in our work. Clamping is the most basic and versatile way to secure our workpieces to our mills, no matter what avocation we're following, and it's a method we'll come back to time and again when our vices, special tables, and fixtures just don't do the trick. Clamping is a very simple process that uses a multi-piece clamp to create a powerful yet versatile system that will fasten almost anywhere on the mill bed. It can give us needed depth on our mini machines when vices and fixtures may place the workpiece too close to the spindle. We can also clamp very large pieces to our mini mill beds, pieces that would never fit in a vise or fixture. There's an ancient and very famous recipe for rabbit stew. It begins, first, catch your rabbit. Before we can begin clamping, we'll need some clamps. The clamp set we showed you before is probably one of the best deals you can get for your mini mill. At the time of this presentation, you could get all these pieces for close to $40, give or take a few depending on where you shopped. Now, if you purchase these 52-some pieces separately, or in smaller sets, you could easily double or triple that cost and still not have the nifty organizer to boot. Now that wouldn't be true economy, and quite frankly, it's fairly certain that you're going to end up needing all these pieces at one time or another. So you might consider this as one of your basic requirements. We'll go through and describe each part in this set, and then we'll show it in use. Let's start with the lowly T-nut. Now this nut is shaped to fit in the slots in the mill bed, providing a movable anchor for our workpieces or fixtures. You'll need a few of these, and the clamping set comes with 6. Next is the stud, which is just a double-ended bolt which connects the parts of our clamping system together. The kit supplies 4 each of 6 different sizes, and there are connecting nuts that will lock studs together to make extra long ones should the need arise. Our next piece is the step block, which is shaped sort of like an Aztec ziggurat or pyramid. These are supports that will enable us to select a wide range of clamping depths. The kit supplies 2 pairs each of the 3 different sizes most useful for our mini mills. The actual jaws of our clamp will be provided by the clamp blocks, which I've also heard referred to as toe blocks, straps, strap blocks, jaw blocks, and once when a machinist pinched himself with one, a few other names I won't repeat. These blocks have one end that's shaped to do the actual clamping, and the other end is milled with notches that match the step blocks. Milled through the center is a slot for the studs to pass through. Now, this milled slot gives us a good degree of adjustability in placement of the blocks, which is important. It's vital that the pressure on our workpiece be balanced very carefully. The kit supplies 3 different size pairs of clamp blocks, again, well chosen for use on the mini mill. And finally, we have the cap nut or flange nut, which tops the whole arrangement off and supplies the actual clamping pressure to our setup. We'll find 6 of these in the kit. Now let's use these pieces and see how they fit together in a simple clamping situation. We'll use the red block to represent our workpiece. We begin by selecting the appropriate size stud and threading it all the way into a T-nut. Then we'll slide this into the middle slot of our bed and close to our workpiece. Next, we'll select a suitable step block and position it on the bed near the stud. The clamp block follows, with the tail portion sitting on the step block high enough that the clamp end is level or slightly lower while resting on the workpiece. This is important. We're going to discuss it more in a moment. And finally, we cap it off with the cap nut, which will snug down at this point but not tighten completely. This will allow us some play to square the workpiece up in the mill. Now, I mentioned that we were going to talk a bit more about the alignment of the clamp block. This is a drawing of a good distribution of clamping forces, which are represented by the gold arrows. The clamp block is supported by the step block in an almost perfectly level position relative to the work surface, and the stud is located very near the work. This directs the majority of the force downward, clamping the workpiece very securely. If the stud is moved closer to the step block, we can see that the majority of the force would then be directed into keeping the step block into place, and less would hold the workpiece. This isn't a good situation. The work could easily shift when milling forces act upon it. As bad as that is, though, this next setup is even worse, and more dangerous. If we let the tail of the clamp block be supported lower than the work surface, so that it has to angle upwards as it contacts the workpiece, we'll have created a very unstable situation. There will now be a component of force that's actually trying to force the work away from the clamp, sort of squirting it out like a melon seed. This could cause the setup to fly apart during machining operations. Now obviously this is a very dangerous setup that we're going to want to avoid. I could rant on for a bit here, but I'm sure you get the idea. So when we clamp our workpieces, we have to keep the clamp block level or angled slightly downward to the workpiece, and the studs need to be as near as possible to the work. Now although the sequence has shown only one clamp on our workpiece, we should, whenever possible, double up. This will help hold the workpiece much more securely and counteract any rotational forces that are going to try to pivot the work around a single clamp point. Sometimes it won't be practical for us to get a clamp on each end of our workpiece. For instance, let's suppose that we want to machine the block that's in the illustration. We want to mill away a section of the left side of this piece. Obviously, we aren't going to be able to position a clamp on that side, and a single clamp on the other side isn't going to be very secure for either holding the work solidly or against rotational forces. So we'll stack two clamps on the same side, anchoring the workpiece on two different points. This is a much stronger setup, but there's still another tool that we need to employ to counteract any rotational forces. It's called a stop block. A stop block is simply a block that's aligned to our workpiece and securely clamped to the bed. Now, as you can imagine, this would be very effective in counteracting any tendency for the workpiece to rotate. It can also be a useful part of a fixture or setup when we want to align multiple workpieces in the exact same manner. You do need to note, however, that the stop block only works against rotational forces. In of itself, it supplies no clamping pressure on the work, so we still, whenever possible, need to use two clamps to fasten our work. There's one more topic I'd like to touch on briefly, and that's the placement of our support blocks. In this illustration, we have a plate that's being clamped over two support blocks. Now, sometimes we have to keep the support blocks clear of where we're going to be milling, or boring, drilling, anything like that, and we need to be mindful of that. But if the clamps are not directly over the blocks, then when we tighten them, we can spring the stock out of shape. This will destroy our accuracy and ruin our workpiece. Instead, make sure that the work is fully supported before tightening the clamps. Watch out for this especially when you're working with bowl-shaped or flanged castings and the like. Make sure that if you're clamping on a flange or lip, that there's a support block directly underneath the clamp. If we apply these principles, our workpiece is going to be much more secure and better able to withstand the surprisingly large forces brought on it by any milling procedure. This will help us prevent injuries from setups flying apart. It's also going to save us time and material from ruined workpieces. Let's move on and discuss how we can align our stock squarely to the mill.